Okay, so we are going to start chapter 10 with parabolas. You guys are a little bit familiar with parabolas. We have done things with them before. We've graphed them in standard form and vertex form, gone back and forth. We're going to talk a little bit more about parabolas today, and this chapter is on conic sections. So we're going to do the four major conic sections: parabolas, hyperbolas, ellipses, and circles. We're going to start with parabolas today. And you can have a vertical parabola or a horizontal parabola. The way I determine whether or not a parabola is vertical or horizontal is by the single variable. So that's going to be y in this case here, or on the right hand side, x. So one variable will be squared and one variable will be single. Whichever the single one, that will determine it. So if y is single, your parabola will be vertical, and if x is single, your parabola will be horizontal. You have a vertex. You don't have a center point. You have a vertex point, which is hk. Your axis of symmetry is a line that goes straight through your vertex and your focus and the center of your graph. And that's x equals h for a vertical, or y equals k for a horizontal. Your focus is a point that your graph will bend around, as we'll see this in a second. And the equation is we're adding p to the y part if it's vertical and to the x part if it's horizontal. So h comma k plus p for vertical, and over here h plus p comma k. And we'll talk about what p is in 1 second. Or p is right here in the equation. Lastly, your it's spelled the directrix. I'm going to say directrix because it's too many R's in a word for me to pronounce. That's kind of like your asymptote. Your graph is going to go away from your directrix. Your graph will never cross the directrix. And the equation, it's a line, and it's going to be dashed just like asymptotes usually are. So y equals k minus p for vertical, and h equals x equals h plus, or h minus p, excuse me, for horizontal. So we're adding p for our focus, and we're subtracting p for the directrix. And we're always adding and subtracting p to the y part, k, if it's vertical, and the x part, h, if it's horizontal. So while you're doing these problems and while you're doing the homework, it might be nice to have this chart right here to show you all this stuff, because it is a lot of equations to work on. And so we can see here, you can have vertical where your y is single, or you can have horizontal where your x is single. If it's positive, it'll go up. If it's negative, it'll go down. If it's positive, it'll go to the right. Or if your graph is negative, it'll go to the left. And here's your focus. You can see the graph really bending around the focus in any of these pictures. And your directrix, your graph is bending away from your directrix and around your focus. P will determine if it's positive or negative. So if P is positive, your graph is positive. If P is negative, your graph is negative. Okay. So, and your focus and your directrix are equally distant away from your vertex. So one is in front and one is behind. So example 1 says, find the equation directrix and graph the parabola, given that your vertex is 2, 1 and your focus is 2, 4. So if we look at what's changed is your y part. That's how I know this is going to be vertical. So I can tell by what has changed. If the x part has changed, it's horizontal. In this case, the y part has changed, so it's vertical. So I can plug, your vertex is hk, and your focus is h, is h comma k plus p. So what we can do is I can say k plus p equals 4. And I know k is 1. So 1 plus p equals 4. And therefore p equals 3. The things you need to plug into your equation are your vertex and p. Now that we know all those, we can write our equation. And our equation is x minus h quantity squared equals 4 times p times y minus k. So plugging everything in, you get x minus 2 squared equals 4 times 3 is 12. So this is 4 times p, and then y minus 1. So this is our equation. You also want to find the directrix. The directrix in this case is y equals k minus p. So y is going to equal k is 1 minus my p we found to be 3. So y equals negative 2. And it's a line, so it has to be y equals, just like asymptotes. So we've done the math now. We found the equation. We found the directrix. Now we have to graph the parabola. I'm going to do my directrix first. Y equals negative 2. It's dashed because it's not really part of the graph. My vertex is 2, 1. I'm going to label that V. And your focus is 2, 4. That's up here. I'm going to label that F. Now, I'm not going to make you make a table to find out exactly where your graph is, because we could do that. We could make a table and be very specific about what this graph looks like. I'm not going to make you be that specific. Just know that your graph bends around your focus, kind of hugs your focus, and goes away from your directrix. We'll say here's the directrix. Okay, so now I want you to pause the video and we can, pause the video and try to do this problem here, same exact type of problem. And once you're done, play the video, and I'm going to continue on with the solution to it, and you can check to see if you're right. So the first thing you want to do is check and see, is it vertical or horizontal? What's changing? And we can see that your x is changing, so this is going to be horizontal. And your vertex is HK. Your focus is H plus P, comma K. So I can say that 1 equals H plus P. And I know what H is because it's in the vertex. So that's 3 plus P. So that means P has to be negative 2. The equation for horizontal parabola is y minus k quantity squared equals 4p times x minus h. So I'm going to plug in my h, my k, and my p. So x minus 5 quantity squared is going to equal 4 times negative 2, because p is negative 2, and that gives you negative 8 times x minus h, which is 3. So here is your equation. And then we want to find the directrix. The equation for the directrix is going to be x equals h plus p, h minus p, I'm very sorry, because this is horizontal, so it's going to be h. And x equals h is 3, minus -2. Two negatives make a positive, so x equals 5. So I'm going to graph that. X equals +5. That's a vertical line. Again, your directrix is a line. It's got arrows and it's dashed because it's not really part of the graph. Your vertex is 3, 5. It's over here. And your focus is 1, 5. And that's over here. And then your graph will bend around your focus and away from your directrix. Okay, moving on. Example 2 says find the focus, directrix, and graph of the equation in standard form. Now, it's not in vertex form, it's in standard form. So what you have to do is complete the square. And when we complete the square, we want to get the squared variable by itself. So y is squared, so we want the y's by themselves. And we're going to move over everything else. We're going to add over that 4x. And then that's going to be +3. We need to find b over 2, quantity squared. And that's going to be, our b is 2 here. Signs do not matter. And 2 over 2, do that first. That's going to be 1, and 1 squared is 1. So that's what we're adding to make this a nice perfect square. Y squared minus 2y plus 1. And what we do to the left side, we have to do to the right side. We're going to add 1 here, and 3 plus 1 gives you 4. Now I can factor the left side, y minus 1 squared. And that's going to equal, I'm going to factor out the 4 here. It's going to give me x plus 1. And now I have my vertex form equation. So now I can tell, because my x is single, that this is going to be horizontal. And we want to find the vertex, hk. H is +1, but we want to change that to -1. We always do the opposite sign when it's in a parenthesis. And your k is going to be +1. This number here, 4, is 4p. Whatever number is outside your parentheses, 4p. So that means p has to equal 1. For your focus, that's h plus p comma k. And my h is -1, so -1 plus p, +1, is going to give you 0, 1. And your directrix is x equals, it's going to be x equals h minus p. We add for focus, we subtract from directrix, and that's going to be -1 minus 1, which gives you -2. So we found the 3 things we need to graph. Let's go ahead and graph it. X equals -2. It's going to go to the right because your p is positive. Your vertex is -1, +1. And your focus is 0, +1. And this would be your focus. This is your vertex. And your graph is going to bend around your focus and away from your directrix. Okay, so this is the end of the first part. Go ahead and click on to the second part of the video.